Hello everybody, I'm Gleb and this is my 6G podcast. Well, probably you may know that it's really hard to predict what's going to be in 10 years in telecom sector. But right now, with you, I'm going to look beyond the horizon and speak about possible 6G networks. So, let's get started. In that video, we're going to consider multiple interesting topics that may relate to 6G networks. I start with two major trends that we can see right now in telecom. Then I will try to talk a little bit about singularity in future networks. Of course, we will consider possible use cases for 5G advanced and 6G technologies. Of course, we will touch a little bit such a tricky topic as political issues and future networks. Definitely, we will consider possible implementations of sub-THz and THz networks with terabit capabilities. So, let's go. I'm going to start with two major telecom trends right now. The first one trend is when everything is multiplied by 10. What do I mean? I mean that every next generation is always 10 times better than previous. We can see that every next generation is 10 times better in capacity, in throughput, in latency, at least when it comes to KPI requirements. And the second trend is not so obvious, I would say, but very exciting. We always introduce something new, something fantastic in current networks, but it became a reality only in future generations. What do I mean? I mean, for example, in 1G networks in first generation, we introduced that concept when we have cell phones without wire, but it became reality only in GSM. In 3G networks, for example, we introduced that concept when we decided to connect our mobile phones to internet. But only in 4G, with all of that social networks and media, we can say only in 4G networks we got the truly internet access. So in 5G, we has already introduced multiple interesting technologies such as artificial intelligence, cloud-based RAN architecture, a very interesting core network. But I believe that all of that will be really the case of 6G networks. So basically we need from 5 to 10 years gap for some technologies to become more mature, to become the real case in our daily life or at our work as engineers or as researchers. So, and even we can speculate about possible 7G networks, yes, because we introduced artificial intelligence in 5G networks, and I believe in 6G it will be the real case. And in 7G networks very probably will be self-synthesized, self-optimized, truly self-planned and self-optimized networks. Yes, we have already it right now in 4G networks even, but in 7G I believe it will be the real case, let's say so. But this is just assumptions, of course. So, what does it mean for us, for engineers, for researchers, for telecom experts? Basically, it means that in 10 years, very probably we will have very smart networks that may basically completely replace your current activities at work. We should definitely look beyond the horizon and at least to try to predict what's going to be in telecom sector. And right now I would like to talk about possible technological progress. So if we look at two curves, we can see that the first curve is just typical one generation of humans. The second curve is our technological progress. We can see that at the start of that curve, in old times, in ancient times, the curve of progress was too long from human life point of view. And it was really hard to see the evidence in your daily life at work, the evidence of technological progress, because everything were the same. I mean, the knowledge of medicine, the knowledge of astronomy, daily life, work, everything was the same for previous generations and for future generations. And basically, technological updates, they could take from 100 to thousands years. Now let's look at the middle of that curves. We can see that at some point technology updates became visible. I mean, the evidence of technological progress would seen daily life at work. For example, you could start your career working as an engineer who worked with a steam engine, but end your career working as an engineer who worked with electricity and electrical engines, basically. Everything became predictable, visible at that time. It was not a big issue. So right now let's look at that part. Right now we are here. This is 21st century. We can see that technological progress became so fast that it's really hard to predict what's going to be even in 5 years. So I'm trying to emphasize that for us, for engineers, for telecom experts, it's really the case to try to look beyond the horizon, try to find new possible skills for our daily work, because who knows, maybe something new will occur and completely destroy all telecom. I mean, maybe, let's say, quantum computers technology will appear and destroy security protocols in telecom. Who knows? And it will completely change our lives. So we should be prepared for any changes, and this is generally your responsibility. And looking at that curve, we can see even with 5G networks, they became in 2 years earlier than it was supposed to initially, 10 years ago. Yes, first 5G networks was launched in 2018, as far as I remember. So you may also say that 6G, 7G networks with artificial intelligence, we finally end up with singularity. All of that put us to a new digital prison, like in Matrix movie. But I believe the question is not about what. The question is how and who is going to control all of that smart networks. Because absolutely the same case with fire or with nuclear energy. With fire you can cook something to eat, yes, or you can burn everything out. So this is the case how you're going to use that technology. Smart networks, this is just a technology, this is not doom, let's say. So it is always a double-edged sword, even from ancient times. So I believe that we should get rid of stupid things, stupid assumptions related to artificial intelligence and singularity, and let all of that computers to replace routine work, and let us to do what we really designed to do. We as humans, we are really good at creativity. Let's do it. And now let's speculate. What is 6G? This is a revolution or evolution? So it is well-known fact that LTE, long-term evolution, was named so in order to emphasize that all next 4G releases will just the evolution of current 4G networks. but the pressure from a market was too strong, I suppose so, and that's why 3GPP release 15 was named 5G. 5G release 15 is the first standard that provide a completely new approach. I mean that all previous generations were more about revolution, but 5G release 15, it is more about evolution. The thing is that release 15 introduced such concept as non-standalone options. It means that with non-standalone option, you can roll out your 5G network easily. You don't have to have 5G core. You can just add 5G base station to your current 4G infrastructure, and basically that's all, with minor software upgrades. What does it mean? It means that this is a mind-blowing concept, because with all previous generations you had to just rip it up and put generation technologies. I mean, you had to build new sites, new core network. But now, with non-standalone, 5G introduced smooth migration from previous generations to 5G networks. In addition to that, I want to point out such technology as dynamic spectrum sharing. That technology is also plays huge role in 5G rollouts, because it allows to share dynamically 4G and 5G resources just inside one spectrum, just inside one bandwidth. So what does it mean? It means that you don't have to special license. You can just deploy 5G inside your 4G spectrum. This is again the second very mind-blowing approach, because it allows you to roll out 5G networks easily and faster using your current 4G infrastructure. I suppose that such evolutionary approach will be continued in 6G networks, and we will see the smooth migration to 5.5G, to 5G advanced, and then to 6G networks. So the timeline between generations. Talking about standardizations, first trials, commercial networks, we can see that the timeline between generations continue to shrink. As I've already mentioned, 6G for different reasons may come several years earlier, before 2030 is expected now. In addition, we may remember that initiative from ITU for 4G networks, called ITU 2010, but the first commercial 4G networks came 1 year earlier. It was December 29. Initially, 5G was predicted by the date of 2020, but first networks came up 2 years earlier. And I suppose the same will be for future networks. The timeline between each generation will become more shorter and shorter, and it will be the evolutionary approach, as I mentioned earlier. In addition, we can see that even with current 5G networks, development and the device ecosystem of 5G terminals is increasingly faster than it was predicted, than it was even with 4G networks. And taking the example of 4G networks, we, for example, may remember that first standard of 4G LTE, it was release 8. It was introduced in 2008, but the first commercial network only in 1 year after, 2009. The first commercial network in the United States was 2010, In UK, it was 2012. So I'm just trying to say that in 4G times, we could see that it took several years before first available release of 3GPP was introduced to build commercial network, to roll out that new generation, that 4G. Even from that point of view, timeline is continued to shrink. Very possibly we will see 6G networks not in 2030, but maybe 3 or 4 years earlier. Now let's talk about ecosystem of devices. If we look at first 5 years of 4G networks and 4G devices, we could see that 21% of annual smartphone sales at that time they supported new 4G standard. So with 5G there are some predictions. In 2023 will be 35% of 5G capable devices. So even from device ecosystem point of view, the timeline continued to shrink, and very possibly first 6G available devices will come earlier than it predicted and expected by 2030 year. So right now let's talk about 6G research issues. I believe that in 3 to 5 years from now we will see more potential weak points of current 5G networks, because in several years from now we will have more killer applications and industrial cases for current 5G networks. But for now, it's really hard to predict the current requirements and technology that should be defined in 6G. For now, it seems to me that most of academia, most of researchers, they try to squeeze, they try to just combine old concepts. Because if we look at 5G, even at 5G, for example, LDPC codes was initially introduced in MIT in 60s. MIMO concept with beamforming, it have roots in military, maybe 40 years ago or even more. OFDM, this is very old concept again. For example, unlicensed spectrum usage is also back to 80s. Virtualization and cloud computers, it is again basically have some roots to SDN and SDR. This is very old concept, back to 90s. Maybe only polar codes was invented just maybe 12 years ago or 40 years ago, 14 years ago. What does it mean? It means that wireless networks, wireless technologies achieved mature state, and there is a very low probability for a great breakthrough. Maybe quantum computers, they will help us in that. So what else interesting here is that for the last 10 years we could see the huge wave of publishing new articles, and it is really sad that most of that articles it was in vain. It was even not read because most of that articles were just describing combining new previous technologies, so not a big very unfocused, very unuseful, I would say even. So I think we should avoid at any cases any unfocused researches. And I know what I'm talking about because 6 years ago, just 6 years ago, I graduated from my university, and I can say that yes, in my university, in many other universities, actually a gap. It seems that there is a gap between academia and industrial reality. Usually students just do not completely realize what has to be performed in their researches and what should be implemented or not from even a commercial point of view. What's more exciting is more players going to be here, partially because of virtualization and open run concept. Such things, it allows to more market players do their own research and participate in 5G evolution and development of future 6G networks. It doesn't necessarily relate it to hardware sector. It may be, for example, related to AR, VR cases. Multiple startups are working in that field. I believe that such startups, they may have at least little impact on future 6G development of future standards. Because the major aim is to bring ideas throughout the research, throughout patents to commercial success. This is the key role. Not doing research just for the sake of research. The true research is always about opening new doors, discovering new territories, new potential cases, and answering the question, which society do we need, may play a huge role in your research. Of course, this is a rhetorical question. It's impossible to give exact answer to that, but it's possible to answer what consumer need, what industry and business needs will be in 5 years, let's say. Another very important point to say is that there is a high probability to move to wrong direction. We can remember the case of WiMax. Actually, WiMax was released earlier than 4G standard. Actually, in WiMax was introduced OFDM, MIMA concept, OFDMA access, and we remember that many companies invested in WiMax instead of future 4G networks. And I suppose most of that was just in vain. It was a wrong direction for investments. We should remember that there is always a case to move to a wrong direction, at least from the point of view man hours. Yes, let's imagine how many man hours were spent to WiMax development instead of 4G standardization and development and rollout. So when it comes to 5.5, 5G advanced and 6G use cases, it is really hard to say exactly what is going to be. So that's why we can only analyze current trends to try to predict the possible future use cases. So one of that use case, so one of that trend is tactile internet, is the internet of sensors. Yes, actually we have already AR, VR applications that actually pretty good, working fine. The true telepresence, the true sharing of skills and sensor, it will be only possible with low latency communication. The thing is that tactile internet, this is the concept which refers to touches, which refers to kinesthetics and movements. Actually, movements and kinesthetics by itself, it does not require very precise and low latency communications, because our response system in our brain, on average, it responds maybe about 100 milliseconds or so. Other senses, such as audio comprehension, also doesn't require very low latency, because on average, again, our human brain cannot distinguish any gaps less than 300 milliseconds. So Other senses such as smelling is extremely low. If we are talking about vision, yes, vision can require pretty low latency latency but again, just maybe 10 milliseconds. It will be enough for smooth comprehension, for smooth visual experience. And even now it is possible with current 5G and maybe even 4G networks. What really requires precise timings and very low latency communication, it is the kinesthetics. I mean, in terms of precise movements and very articulate manipulations. Yes, robots can definitely win any grandmaster playing in chess game, but robots still cannot remove any figures after the play in the games. So, because all of that manipulations, it requires very low latency, it requires very precise kinesthetics within very short time and short distance. Well, actually, one of the cases of tactile internet is the remote surgery, because in remote surgery, we also should do some manipulations and movements within very short time and within very short distance. So that's why remote surgery, it also may relate to tactile internet. Well, basically talking about the internet by itself, it made a really good job. I mean that fact that 25-30 years ago you had to go to library to find something, to read something, to highlight with your pen some notes. Yes, but now with internet, most of information, almost any information is available, is accessible, especially when it comes to using mobile internet, wireless networks at any time and at any place. So internet, we can say, democratize information, and tactile internet is going to go further. Tactile internet is going to democratize skills, experience, and knowledge. That's the case. This is not just the technology which requires low latency communication. No, tactile internet is going to completely change game. And actually, one of the possible solution for reducing latency requirements, for reducing difficulties and context of such networks for tactile internet, is to applying AI and ML algorithms. So we can predict missed data, for example, or we can predict some actions in visual, in kinesthetic format, and play that in AR, VR helmet, for example. We don't have to retransmit information, we don't have to wait for additional processing of working some codecs, yes, to compensate some errors and fails. It can be done via a simulation, it can be done via application of artificial intelligence and machine learning algorithms to visual context, to kinesthetics, and in that sense I believe it can work out, it can help us to overcome that physical limits, because when we're talking about the cases, so when we need to transmit some information, I mean in tactile internet networks, yes, from one continent to another continent, of course it will reflect with pretty huge latency, yes, because it is impossible. There are some limitations on physical layer, radio wave propagation, and even some information theory that also has borders and limitations and applying artificial intelligence, it can help us to overcome that limitations. In addition to implication of artificial intelligence in Internet of senses, Internet of experience and skills, we can add a rendering and processing at clouds. Yes, this is pretty old concept, but I think, again, it is already introduced, but will be in mature case in 10 years, let's say, in 6G networks, because it is a really good case when we can do some processing and rendering somewhere at edge, not inside our mobile device or IoT device. It will definitely reduce the final complex of that device, the final cost of that device as well, together with artificial intelligence amplifications and rendering and processing that information somewhere on clouds. It may be the case for developing tactile internet on daily basis for everybody among us. So basically all of that concepts of tactile internet, VR rendering, all of that, it relates to synthesized, synchronized world. A world when we can merge digital reality and physical reality. And this will be the case of future 6G networks. And right now I would like to talk about reconfigurable intelligent surfaces. So we can call them Metasurfaces as well. So it is well known fact that the radio waves in the real environments, they behave very differently. They can, when radio wave meet obstacle, some part of energy can be absorbed, some part of energy can be reflected, and actually that principle is used in reconfigurable intelligent surfaces. It says that we can change the properties of that surfaces, that obstacles, in order to reflect radio waves in that direction that is required for our transmission. Yes, so basically we can manipulate with settings of that surfaces, and it will lead to necessary reflection towards a receiver. We can use such surfaces to cover blind areas in dense urban environments, in indoor cases especially, and especially this is the case of millimeter waves and sub-THz communication, because with that radio waves, radio wave behaves like a laser. It cannot bend and overlap everything, so it is just very straight, and every obstacles for millimeter waves, for sub-THz is a fatal obstacles, let's say so. And with the concept of metasurfaces, we can overcome that limitations of higher frequencies. This sounds very marvelous and fantastic, I would say even. But the question is how such surfaces is going to be utilized by operators. How they going to be maintained, how they going to be built, because in order to make such surfaces works, they should be covered in many places, outdoors, in indoors, only with multiple surfaces we can achieve pretty good results. It means that such additional equipment, it will be additional asset for operators to maintain, to build it, And again, this is the question actually. Actually, reconfigurable intelligent surfaces, they've already added as a potential candidate for 5G release 18. And I believe they will be a candidate for 6G networks as well. Probably they should be considered as some kind of smart repeaters that can repeat signals in necessary direction. When we can put such surfaces in between transceiver and receiver. One of the possible area when we can apply reconfigurable intelligent surfaces is precise indoor positioning. Another case is, as I said, as I've already said, is the case of repeaters, and the case of repeaters for covering indoor areas from outdoor signals. So such surfaces, for example, they can cover walls in office areas, inside buildings, and just reflect the useful signal from outdoor, from millimeter waves, from sub-millimeter wave networks. So there are already multiple researchers, investigations, and academia put into reconfigurable intelligent surfaces. Actually, one of the best well-known men is Emil Björnsson. You can find his channel on YouTube. I strongly recommend you to go to his channel and watch videos related to massive MIMO, beamforming, reconfigurable surfaces. This is very interesting, very insightful lections. So I really recommend to visit his channel. Of course, there is a need from academia point of view to think about what kind of materials should be used in that surfaces, what kind of filters, passive antennas or active antennas, or maybe clusters of multiple antennas. So what kind of techniques and materials should be used in that surfaces? That's the key point as well. So right now let's move to terahertz communication and terabit per second throughput. So before to start talking about that communication, I would like to make some questions about what do we need in order to increase area capacity. So basically we can build more sites, we can densify our network, we can also go to in the way of increasing spectrum efficiency. We can apply high order MIMO techniques and high order modulation schemes. So what else we can say? Increase the bandwidth of our communication. And nowadays, the only possibility to increase the amount of spectrum dedicated to our communication is only in the way of moving to high frequencies, in the way of moving to millimeter waves and sub-terahertz spectrum. So this is actually the old trend in wireless networks, moving to higher frequency in order to be able to allocate huge amount of spectrum for our communication. And actually that's again the questions. Why do we need terabits per second for users or even for cells? Is it really required from application point of view? I mean, from AR, VR, and Tactile Internet, holograms? That's the big question. Probably even from that point of view, it will be enough to use frequencies below 1 terahertz and even below 0.1 terahertz. So operating in millimeter waves will be sufficient and a case for future 6G networks. But okay, let's imagine that terahertz spectrum, terahertz frequencies is going to be used in future generation networks, and actually that's not new. We've already used that frequencies in some medical applications. We already used that frequency in astronomy. So, but we don't know how that frequencies behaves in terms of applying them and using them in wireless networks, in mobile communications, with low latency requirements, with high resilience. So that's the case for future research, and that's definitely the case for trying to understand what kind of amplifiers, what kind of radio equipment and filters we need to for operating effectively in that new spectrum range. When it comes to terabit per second, I just want to emphasize that I'm and most of researchers, most of telecom experts, they are really skeptical about that need of terabits per second, because it is only possible in terahertz communications, in terahertz waveforms, and such communication is only possible in non-mobility cases. So yes, we can say that terahertz spectrum with terabits per second cases can be seen in foreseeable future, but maybe only as a case of front haul connections, back haul connections, where there is no mobility, when there is no strong requirements for fast movements. So yes, that's the case. We have to understand that operating in terahertz frequencies, it is always the case of only line of sign and maximum within 100 meters, because dramatical power loss, it's extremely hard to support a link budget. Yes, maybe it will be possible due to beamforming, MIMO techniques, yes, to support that communication in downlink direction. But what about uplink direction? With uplink, it is always a bottleneck for multiple wireless networks. And again, this will be the case as well for 6G networks. So to summarize, topic related to terahertz networks and terabits per second, I guess this is more or less about marketing, because there are multiple researchers, pretty good researchers related to sub-THz communication, related to 340 gigahertz or 100, 200 gigahertz. There are some possible ranges that can be useful. I don't see just strong requirements for using terahertz, just terahertz communication in future networks. Maybe again, maybe only in cases when there is no mobility requirements. Yes, maybe in that cases. So again, this is just marketing, this is just hype to emphasize that 6G and terahertz will be together. Probably no. This is actually the same story when we're talking about generation terms. There is no G in 3GPP specifications. There is only GSM, UMTS, HSPA, LTE, NR networks, yes, and G is a marketing word. So the same story with terahertz communication. Terahertz is just overhyped and marketing word. And as I said already, there are multiple other ranges in spectrum that can be in very useful way to use for 6G purposes. Okay, just a few words about artificial intelligence applications in air interface. I've came across with some sources related to that, and 5G introduced software not only in core networks but also in radio networks. I mean, softwareization with all of that cloud capabilities. And of course, it will give us the further path to applying very processing smart algorithms to predict behaviors of radio waves, and maybe to eliminate, to overcome some limitations and gain throughput and reduce latency in radio, in air interface. That can be the case, I believe so. So right now let's move to new IP topic. Actually, I'm not a networking guy, I'm just specialist in radio networks, in mobile networks, and I see a great opportunity to speak about of proposal Huawei company on new IP protocol. So as it said, new IP is not intended to replace old TCP/IP stack. It is just supposed to support current TCP/IP protocols. The first point is there is no any standards related to that. There is just one document, one, let's say, white paper that was based by Huawei company, and that's all. The second thing is that there is pretty huge amount of investigations that was made by such company as ICAN. That investigations is actually based on a proposal, which I've already mentioned. Actually, the link to that documents you can find below in under that video. So in this document, ICAN organization, they made an assumption that creation of new IP protocol will help to Huawei to spy over their equipment, over networks. Maybe it is the case, but it is hard to believe. Actually, again, I'm not a networking guy. I don't know exactly how it works with every precise details, but I think this may not be the case, because again, it is not about the replacement. It is just the thoughts on how to easily configure networks. Huawei proposed to make a variable length of IP address so that the IP address can use just 4 for IP4 and 16 for IP6 digits lengths that can be needed in very specific scenarios. So it says on also that let's say for devices talking to each other, why don't we use every time long address such as 127.0.0 blah blah blah, yeah. Instead of that, we can use just short address in IP head, in IP header. So this is a little bit faster, but again, I think this is not the case of throughput. This is the case for IoT devices, for industrial implementation. This is the case of just how to configure network in easier way, using shorter addresses where it possible. Another interesting point on that is new IP is supposed to add such kind of additional meta information in special IP header that can help to determine which packet can be rejected or which packet can be delivered without precise IP address, or what can be done with the packet in advance. As I understand technically, it can help to filter some kind of DDoS attacks, which actually still is relevant to multiple networks. So a new IP supposed to suppress, to avoid such type of attacks, because inside IP packet will be special additional meta information which can be read by equipment. Based on that can be a decision to switch off traffic or not to switch off traffic. Another interesting point is that the possibility to avoid DNS servers. This seems to be useful because it removes the centralization concept of internet, of DNS servers. Because DNS, it is still a centralized service that exists in somewhere on the internet, which decide to whom to give the names, yes? And new IP can be very useful in terms of decentralization of network. In addition to that, new IP may be considered as some kind of threat because it will eliminate that concept of DNS. And actually, ICAN organization, this is the main organization which provide DNS services. So that's why I guess ICAN makes some contra toward Huawei proposal on IP, on a new IP protocol. So from my point of view, I strongly appreciate new concepts, new attempts to try to make some revision of old concepts of old TCP/IP stack. I think it may play a role in future networks, especially again for IoT devices and industrial cases. But we should not be very confused by political issues related to companies and countries, because only working together we can achieve what we've already achieved in previous networks. Okay, just a few phrases related to political issues and future generation networks. So, as you may see right now, the world is going to be divided in two parts. First part is where China dominated, and the second part is where Western companies and countries dominated. So, of course, the main reason of that is the current confrontation between the US and China. It actually means that such companies as Ericsson, Nokia, Huawei, ZTE, they will have to work on their own standards. They will have to develop completely two different standards for each part of the world. Such confrontations, geopolitical area, it is always lead to split up in standardization area, in science area. And this is definitely not the case of our 6G networks. We should definitely to avoid that with all cost. It will the reduce of speed of researching. It is better to accumulate all our power, all our research abilities together, as we've already done with all previous generation networks, as we've already do it with within 3GPP organizations, within ITU, IEEE and ITSE organization. 3GPP, for example, is really good case. It works in very decent way, in very democratic way, where all companies and countries presented and can influence on different standard parts. So that's actually the case. Another topic that I would like to emphasize is that right now in 2021 we can see that Huawei and some Chinese companies, they came into ideal storm situation, let's say so. So they have maybe some issues outside of their country, but at the same time they have issues related to processor making. This is not just a problem of smartphone business, yes, because processors they use everywhere in mobile equipment, in network equipment as well, and without really good and advanced processors it will be really hard to deploy advanced MIMO techniques, beamforming techniques. But I believe that China and Chinese companies, they usually play in long games, and they will overcome that gap from Western companies. We should just wait maybe a few years and we will see new processors from China companies. Of course, there is no secret that China is going to is trying to be more independent in terms of technology. So they right now don't have access to US equipment and tools. Of course, this is not a process of one night, yes. But again, as I said before, China, they know how to play long games, and they will overcome that obstacles as well. First of all, when we're talking about geopolitical issues, we should not end up with a situation when we have two different standards. So again, as I said before, it is better to accumulate all resources, all abilities to work in that way as we've already do it right now, to keep it for future networks, because only working together, only with collaboration, that's the real power of as humanity. So on that point, I would like to end my podcast. I hope you enjoyed that not so long podcast about future possible 6G networks, use cases and requirements. So if you like that podcast and my channel, you can subscribe to my channel and wait for new videos. So and for now, that's all. I would like to say thank you for listening. Goodbye.